This, strangely, is what one sees in parts of Iceland at the present day, where animals have been kept away from the woodland. And indeed, one wonders if this was what things were like when Ari the Wise was writing. He said that at that time Iceland was covered with woods between the mountains and the seashore. The extent to which this might have been true may be ascertained from sagas and other writings. And in this map here, if you look at the red dots, these indicate woodland. And this might give the impression that Iceland was very well wooded during the period that those medieval documents were being written. But what is the reality of this? Well, let's look a little bit further, and it's one area around the ecclesiastical centre of Reykholt. And in the documents there, one sees also that 60% of the citations are to woodland amongst the vegetational references. And the question of woodland cover can also be assessed by looking at some modelling activities over recent times. And here we see that Ólafsdóttir estimated that at Landndim birch woodland declined from 7% of the vegetational cover of Iceland down to about 1%. A slightly different modelled value from Arnold's, who said 25% at Landndim, down to about 1% in 2005. What we do know is that obviously woodland would have been of importance, or woodland resources. And if we look at this recent paper in Archaeologia Icelandica, we can see an assessment of woodland needs. And so if you take a house, a dwelling such as this reconstruction at Eiríksstaðir in the west of Iceland, the suggestion here is that simply to keep this dwelling going, heating and cooking, it would have required 11 meters squared of timber. If these people, as they were in many places in Iceland, also involved in smelting, just to produce 15 kilograms of iron ore would require the charcoal from 60 meters squared of woodland. And we know that the woodland resource was used for heating, and certainly in high status locations, and that at Hofstadía, as we will see in a moment, does have micromorphological evidence for the use of wood ash in fires, whereas low status places, certainly as soon as wood disappeared from around those dwellings, would have had to rely on, to a degree, on peat, but even using animal dung. And the fact that by the 18th century half of Icelandic farmers were still able to access woodland for firewood is strongly suggestive that woodland management had to have been underway, had to have been undertaken, and perhaps this is much more widespread than was previously thought. Pollen analytical evidence can give us some insights into this, and let's just simply take a whole series of sites, many of which we've been involved with, and look simply at the birch pollen record. And if you look between the time periods of Landndim and up to the nominal end of the Norse period, as demarcated by the Katla 1500 tephra, then we can see that there was woodland at the time of Landndim, just as Ari had suggested, but in fact it was already declining. We think it was declining because of deteriorating climate at this time and or in this area. And here you see the Landndim ash there, it's 871, and the birch curves, the birch pollen curves are on the way down. If we look at Kettlestad here, down here in the extreme south, then in fact one couldn't argue about wooded everywhere from mountain top to sea, because here woodland and birch woodland hardly figured in the record. It was a very low quantity, as we shall see later. At this site in the west at Breidavatten, woodland is declining from Landndim onward, so this, if you like, fits the model as is seen at a number of sites in Iceland. And yet we can find in the Mývatn site of Hellevatnsjön here that woodland was continuing, or the birch woodland seems to have been continuing well beyond Landndim, which has a suggestion or a hint that assuming that people were living in this area, which they were, then management was being undertaken. And this is all part and parcel, if you like, of the ecology of any farm or any area during the Norse period. And let's look at one of these, Hrísbrú here. And this is part of the Mosfjella area, and in the Mosfellasdal, in the valley of Mosfjella, then Jesse Byack and his team from Los Angeles, with other people being involved, have been looking at a very substantial dwelling house that figured, or seems to have figured, largely in some of the sagas. And there's Jesse talking about the discoveries at the site of Hrísbrú in Mosfjella, and burials around the church, which is not uncommon, and even including an individual who'd had his head stoven in with an axe. And if we look at a pollen diagram from Hrísbrú undertaken by Egil Erlendsson from Aberdeen, now of Reykjavik, you'll see that at Landndim we have barley pollen appearing, and nothing before that. We also have, prior to Landndim, lots of woody sedge peat, so there's woodland in the area. And then immediately after Landndim here, we get on to a silty peat with cultural remains, but no signs of wood in the stratigraphy of that core. And the fact that we move from peat to silt is indicative almost certainly of erosion, and in this case the silty inputs and the minerogenic inputs into these sites are suggestive of soil removal and its transport through the atmosphere or overland down into these sites. And let's explore this a little bit. Here we have a map of Iceland which shows that something approaching 40% of Iceland has a serious erosional problem, and that's indicated here by the pink and the red areas. The red areas are those which have suffered most extensively from this. And we can see this today by these eroded areas, one side of a fence which is keeping animals from the area to the left, but on the right in this case sheep erosion, has caused extensive destruction of the vegetational mat and erosion of the underlying soils. And you could see this, of course, in parts of Scotland also. This is not confined to Iceland, but it's probably characteristic of what was going on during the Norse period, and we can see this in the environmental record. Here's another indication of prime grazing land in Iceland at the present day with soil erosion. This is helped by the very friable soils that result from volcanic activity. And these soils, these anthrosols, are easily eroded, and sheep is seen as the main culprit, but this, to be quite frank, could be any animals who, once they start to break the surface vegetational mat, the elements get into these very fragile soils, and we start to see erosion on quite a grand scale. And one can see this in many parts of Iceland at the present day. We'll see more of that in a moment, but just to indicate to you that one of the tools that enables us to do that is tephra, which we've talked about fairly extensively, and Hekla is obviously a volcanic name that will be known to most of you. And Hekla has produced tephra, has produced eruptions over many years that are known historically, and this provides us with tephras which are distributed by the wind over very wide areas of Iceland and all the way across to mainland Europe. And this gives us a great dating tool for looking at and assessing environmental degradation. And here we can see multiple eruptions of Hekla again, and the various thicknesses of deposit in, for example, southern Iceland. And let's just indicate how we can use this as a dating tool. Here in a trench in southern Iceland, one can see lots of tephras, and these tephras contain the actual glassy shards of the ejecta from the volcanoes. These tephra shards can in effect be fingerprinted by an electron microprobe. We can look at the chemistry of these and assign them over large areas to specific eruptions. And if one looks at the suites of tephra that are often to be found here, then a number of them are known historically, and this is indicated here. It's not just Hekla, of course, but Katla and so on. There are lots of different eruptions that have been known and their dates recorded. We can have the earlier ones, which are also detectable in the Greenland ice cores, and the Greenland ice cores are giving us independent dating evidence. It's just like a tree ring analysis. One can date from the present surface of the Greenland ice cap down through time, and then locate these and date these earlier tephras that may not actually have historical records associated with them. In addition, in any one site, one can look at the depths of material and the time it's taken before another tephra has arisen between all these tephra horizons, and this gives us an idea of the dating intervals and how much material has been deposited since the last eruption. And one can use this over time and over space to reconstruct, if you like, land surfaces and how much material has been deposited. And this material, of course, has been eroded from elsewhere. and these tephras, as indicated, can be mapped across wide areas. And I think this diagram here shows this quite neatly. Andy Dugmore and colleagues in working in the south of Iceland have over many years been able to record this activity and map past patterns of tephra deposition and soil erosion and deposition, and to relate this to activities in the Norse period. And if we look at this area around Eyjafjallajökull, over quite a wide expanse, probably around about 30 kilometre area, then one can reconstruct what's going on spatially and chronologically. Here we have sites spread over that area, and we have altitude as one dimension, we have time here. And then we have Landndim, indicated by the red line. And what this means is that pre-Landndim, before the Norse have actually arrived, you can see that the extent of the tephra is very small. So there's very little sediment accumulation. And then we're hitting Landndim, and almost instantly, or perhaps not always quite so instantly, but very soon after the arrival of people, then we start to see the increasing deposition of eroded material, and this is all dated by the intercalated volcanic ash layers, the tephra layers that one finds in the peat deposits, in the soil deposits, and indeed in lake sediments also. You can also see that the higher the altitude, then one's often getting less deposition of material. More recent work in a more narrowly constricted area here is giving us a higher resolution, which is rather interesting. Here we can see the Landndim horizon, and we can see that up to about 1500, in other words covering the Norse period, we see quite a lot of variability in the amount of material deposited, and that really more material has been deposited since then, and we are after then certainly getting into the severe climate downturn of the Little Ice Age, and so this is quite a complex picture. If one looks at an idea of what's going on at specific sites, at Landndim, you can see from those quite small red bars that there is an instant increase in deposition of material, but this accelerates between about AD 920 and towards the end of the Norse period. There seems to be, or one can certainly infer, that there's increased intensity of occupation of these areas and increased degradation of the landscape leading to erosion, but it continues right through, in this case up to the 1947 tephra. Arguably, the human impact has started a process which just continues and becomes exacerbated as a result of the Little Ice Age, but it's very difficult to avoid the suggestion that there is an extremely strong human component in this whole process. One can look at this climatically via empirical evidence on the ground and modelling activity, and the Edinburgh group have been involved in this for a number of years as part of our project, and into their models they can factor a whole series of things, and some of these are indicated on the little list here. And for one area, in the Thorsmork area in the south of Iceland, where there's been a lot of destruction of soils, a lot of soil erosion, and a lot of settlement abandonment. And the modelling work here indicates that the erosion and the abandonment was occurring before the Little Ice Age, and so there was human activity going on in there at quite an extensive scale. And what the modelling indicates is that if you depress the temperature by about 1 degree centigrade, it wouldn't cause the changes that we see empirically in the vegetation and the soils from that area. However, if we increase it 2.5 degrees, then we would see things happening. But we know from the glacier limits in that area that the temperature didn't go down that far. It didn't happen. And so what this is strongly suggestive of is the fact that it's humanly induced rather than climatically caused changes to the landscape that have brought about the damage that one sees to the soils and the vegetation, and hence to the ecological resource that existed through the Norse period in the Thorsmork area. Let's go to a different area and see what we can find. If we go to the Breidavatten area, then a core from this lake shows that we have pollen evidence from Landndim indicating a reduction in woodland, and I've simply put up the birch curve there. We have a reduction in birch together with an enhancement of deteriorated pollen, which is the grey silhouettes, but it's not huge. Strongly, and this damaged pollen is probably from pollen that's become incorporated in soils that are eroded into the site. What it paints is a picture of woodland removal and some landscape destruction, but it all appears to be fairly manageable, and there doesn't appear to be wholesale soil erosion. But shortly after about 1300 AD, then we have further sharp reduction in woodland and a great increase in the damaged pollen component, which is very strongly suggestive of soil erosion and by inference damage to the resources, a limitation on the resources in that area. And in the magnetic susceptibility curve we see also another proxy indicating erosion within the catchment area of the Breidavatten site. That a bit later we have from the chironomid evidence, from the non-biting midge evidence, an indication that there was a 1 degree centigrade fall in temperature through here, and that may well have been exacerbating the situation. But quite clearly things were happening somewhat before the fall in temperature here, but these things work cumulatively and together and indicate that we are looking at damage to the environment, in this case from the late Norse period especially onwards. We can see this as well in a number of lake sites and peat sites, and we see this particularly and here I'm talking especially about soil erosion in the stratigraphy of these deposits. Here is a lake site to the north of Reykjavik, and here's the Landndim tephra. And if we look across that in higher resolution, we start to see in moist soils indicated by the organic content here. We see it in the colour change. We have a lot of material that's light before Landndim, and then at and beyond Landndim it gets dark. This is because we have increased inwash of these organic soils into our lake, and that's what's being reflected in the stratigraphy. And we can see this in peat bogs. Here we're going back to the site of Hrisbru in Mosfjella, and here's the Landndim ash. And in this basal peat we have a sedgewood matrix with lots of wood visible in the stratigraphy. Landndim indicates the arrival of people, and almost immediately afterwards we have a colour change. We have a silty peat, strongly indicative of minerogenic material, soil, effectively wind-blown soil being blown into the site, in some cases washed into sites where these are valley bottom mires which have got hill slopes adjacent to them, so that soil wash and erosion can then flow over the accumulating peat surface. But whatever way you look at it, it's remarkable that this occurs virtually from the point that people arrive on the scene. If we look at the site of Storemork, and we've already seen the pollen profile from there a bit earlier, Storemork means big wood. But you go to the area and you say, well, what happened to the trees if this is the case? Well, look in the ditches. If you look in the ditch at Storemork, this is what you see. Here you have the Landndim ash, and there's the Catlan 920, the AD 920 ash as time references. Here we have wood remains in the peat as both macrofossils and as pollen, and by about AD 920 it's gone. But you look around in those ditches and it's not difficult to find very substantial trunks of birch. The use of this wood can also be seen virtually around the corner, a few kilometres on, of course, up at the glacier front. And here, where a stream has eroded the glacial soils of the area, and in the sides of the stream channels, in the bluffs, you can actually see a deposit of charcoal. And these are very small pieces of charcoal. This is a phenomenon or an entity called a charcoal pit, of which many are known in different parts of Iceland. And here we've got upturn from the creation of that pit, or the processing activity associated with it. And the pit was cut into Landndim ash, so it postdates that. And here's a later ash, that's a Hecla 1341 ash. And one can model what the age of this deposit and constrain it by various methods, radiocarbon as well as tephra. And this would indicate that the charcoal that was being processed, was being made in this charcoal pit, dates to that period, which is gives us a very good idea of when things were going on. So in other words, the first half of the 11th century AD here. And we need that charcoal, or people needed that charcoal, for things such as smelting activity. And you can look at the reddened peat deposits around a house in Reykholtsdala, which was a major smithing site in Iceland. And the charcoal fragments that one finds in the charcoal pits in the Gigajökull area, in that particular pit and associated ones with it, indicates that these are coppiced woodlands, and that many of these woodlands were, many of these coppices were harvested round about 7-8 years old. So they're really going quite specifically for a material of a certain age, a certain size, in order to manufacture charcoal, mainly for, one feels, for iron smelting. And this evidence, which has been worked on a great deal by Mike Church and others, is giving us a fantastic idea of woodland management. And if you look in the area around Storemork, where we have our pollen evidence and various other macrofossil evidence from dishes and so on, we can see that the woods were cleared in the 9th to 10th century. And if you move further inland, then we start to find the charcoal pits, which are giving us a somewhat later activity, and right through to Thorsmjork, where one has surviving woodland, and it's strongly suggestive of a movement of management inland. And up at in the Thorsmork area, one can still see the remains of woodlands, and this is Husadal, a Norse settlement site, and with surviving woodland around it. And one can see this reflected, arguably, in the pollen evidence also, where we have the area that we looked at a moment ago around Storemork. There's the Landndim ash, and here we can see the reduction in the pollen of woodland, and that fits with the evidence for such activity on the ground, in the macrofossil evidence. And then if you look at the wider area, that would be what's indicated most directly by most of the pollen, that shaded pink area around our site. But what we can see in the pollen is this further reduction in here, and that seems to be reflecting what was going on in the charcoal pit area beyond the immediate pollen sampling area of the site. And then as we go further away, we start to see a further reduction in the woodland, which would correspond to other charcoal pit evidence further away again. And so there is quite a good correspondence between these things, recognizing all the problems that one has when you're only dealing with one pollen site here, for example, and not multiple pollen sites. But what we're seeing here is, I think, this movement of woodland management further inland, up toward Thorsmjork. So it's not a story of rapid depletion everywhere, it's a managed activity that's been going on. And if we move from that area of southern Iceland up towards the north, and we can see what was happening in a completely different area when the Norse were active there. This is the area around Mývatn, and in here we have lots of, numerically, certainly hundreds, if not thousands, of charcoal pits in known groups. There are undoubtedly many more to be discovered. And on the ground, these charcoal pits look like these depressions with a kind of donut around it, which isn't brought out well in the photograph, but a very slight mound of material, processing material, very similar to what we saw, if you like, buried in the site, in the stream side down in the south of Iceland. And let's look further at some of this. And here we can see one of these charcoal pits under excavation from the surface this time. And here we are. And let's look at them on this false colour image photograph. You can see them all over the surface of this plateau. And to give you an idea of scale here, there is an individual, another one of Arne Einarsson's wonderful photographs. Let's look at this in a bit more detail. If you look at the site of Elevation, one of our pollen sites, where we have Landndim ash and Vedvoten 1477 ash here, and we can see between those dates that the brown silhouette is indicating a decline in the birch pollen curve. We have to move, I'm afraid, up to this area around Hoskelstadia, but the interesting thing is that there are lots of charcoal pits in that area that have been dated, and these actually, if you look at the dates of those, when coppicing activity clearly and charcoal production was underway, it fits very well with the decline that one sees a few kilometres to the south at Hellevatshøen. And although these are spatially dislocated, I think chronologically this is very interesting and may well indicate that across this whole area at about the same time there was this woodland management going on, and we can see this both in the pollen record as well as in the artifactual record. What about the wider ecology of that particular area? Well, we've discussed this in a whole series of papers, and it is a marvellous area, will be known to many holidaymakers. It's an area of both that's rather verdant as well as heavily eroded, and the I suppose in landscape terms the pseudo craters are what particularly makes this area famous from a tourist point of view, as well as the many midges that people are aware of. And Mývatn indeed means midge lake. The saving grace is that these midges don't bite. Archaeological investigations have been going on here for many years by a team, Icelandic and American teams involving Ari Vestensson and Tom McGovern and others, with lots of environmental input from Stirling, Edinburgh and Aberdeen. And let's look at this area around Mývatn. We're about 60-70 kilometres from the coast, and archaeologically we have farms that are permanent farms that were there in the Norse period and managed to hang on, but also a lot of abandoned farms also. And let's look at what was going on in terms of this fuel utilization. And here we have one of the sites, famous sites, Hofstadía, where we have the largest known longhouse in Iceland, and we can contrast it with a site that did not survive as a farm, Svegakot, just a matter of kilometres to the south. And in this work reported by Ian Simpson and colleagues, we can actually look at the fuel that was used at the sites. And if we look at Hofstadía, the soil micromorphology shows that they had peat being used as a fuel, but also wood. So both of these ongoing, whereas that abandoned site that became a somewhat impoverished site, the site of Svegakot, they were actually burning cow dung for at least part of the life of that site. strongly suggestive that this was a pretty low status farm. And looking at the use of peat, for example, in that area, we can see that peat is used in many of the buildings. As we saw this, we see this in Iceland. We saw this, of course, in the Faroes and throughout the Norse world, North Atlantic world at least. And in here at Hofstadr, you can see, if you like, the different architecture, the different structure of the buildings, different parts of buildings, in the form in which the fossil turfs or subfossil turfs survive. And we can see this right through to modern buildings today. So Norse at the top and modern buildings below. Exactly the same processes and methods still being used. Very interesting ethnographically. What about the food resource? Well, here's Hofstadr, and we can see here that there were cattle, but numerically then it was sheep and possibly goat. But this still only represents 24% of the faunal remains. Most of it was fish, and we see that here, where we have, well, the pink indicates the salmonid family, so salmon and trout, but also some cod. And here at Hofstadr, we're a long way inland, as we shall see. Here's Hofstadr and remains of cod, 60 kilometers from the coast. So this was transported. Only the red parts were brought in. So the head parts and the tail were obviously part of the processing activity. These would have been left on the coast, and nice fillets were delivered to Hofstadr. Also, we have common seal. This is a long way to bring seal steaks. Porpoise down here around Svegakot, the rather damaged site that we saw a moment ago, but also using whatever locally is available, and eggs. Lots of eggshells found from ducks and geese in the area. And we look at the isotope evidence in the bones of the people, and this seems to show a relationship between marine foods and distance from the sea in general. And this would be unsurprising, despite what we've just seen at Hofstadr. Then the amount of marine intake was highest at the coast and least inland. We can look at the Icelandic situation here superimposed on the Greenlandic one. And what we see here is that throughout much of the Norse period, this rather garish purple cluster or clusters are suggesting a predominance of terrestrial food sources for people. And as one goes through time in Greenland, and this is something we will return to, there is a supposed increase in the marine food intake. So fairly terrestrial in much of Iceland for the period that we're looking at, and this has been brought out by recent work that's just been published by Philippa Askoff and co-workers on pagan graves in Iceland. Looking further at Hofstadr, we said that a lot of the food resource, as far as the animals were concerned, was sheep or sheep-goat. But very interestingly, at this site, we have 23 skulls of cattle located around the site, and a single still articulated sheep. 23 skulls is a great many, and this monograph that's recently been produced by Gavin Lucas on Hofstadter with a marvellous compendium of information of all kinds, excavation, the economy, the environment at the site. This is fairly unique, this site, as far as the Mývatn area is concerned, and all these cattle skulls would seem to indicate a great deal of ritual activity. And this isn't just because of the number of skulls that have been found around here, and a lot of them were somewhat corroded, suggestive of the fact that they may have been on display inside or outside of this site, but it's the mode of killing here. And it would seem that the cattle had been poleaxed between the eyes to stun them, and then there were axe cuts immediately behind the head. And what this would have had the effect of doing is, as soon as the head was chopped, then because the animal was stunned, then I'm afraid if you're a weak stomach, you might want to block your ears for a moment. Then the blood would have pulsed out of the animal, somewhat like a fountain, and it's probably part of the ritual associated with feasting and patronage, something that's a growing subject of study in Iceland and elsewhere for the Norse period. And the fact that we also have a sheep in one of the sites where we have most of the skulls as well, that had been poleaxed, not been butchered in the same way as one would find sheep normally, suggests ceremonial use of what is here called a feasting hall. Looking at the area in terms of modelling activities, then one can also see that the declines in temperature that would have taken place through the Norse period would have led to a reduction in the quality of the landscape from a farming perspective. If you look around here at Sveigakot, for example, then Sveigakot at the present day, relatively warm, is fairly or potentially a grassed area, but if you had a reduction in temperature then of 1.5 degrees, it would greatly reduce the amount of grass and woodland that would be available to the area in the vicinity of a farm like Sveigakot that did not survive the Norse period. So we see that kind of reduction in useful land cover, and we see this in terms of the modelled growing season, because Sveigakot here has much of its land area available to it. It would able to, the crops would grow, or the grass would grow, if we're talking about crops, certainly up to September, with some around August. But if you reduce the temperature by 1.5 degrees, then you're certainly reducing the growing season for maybe up to half of the land area available to the site, and so that we're seeing that July and August is virtually the end of any useful grass growth in that area. And looking at another site close to Sveigakot, we have Rhind, which also didn't survive, and this area here has quite a lot of denuded soils, but not totally. Though the nice green areas you see there are rather wet, and there are mires there as well. This actually shows us two graves on top of a glacial ridge at the Rhind site, and one of these is actually a dog burial. And the erosion here is not dissimilar from that around Svegekot. To give you an idea of this, this is an eroded surface, and Andy Dugmore is standing right in front of a tephra relating to 800 years ago. And so we're seeing a lot of destruction here. And here we can see a field wall, but it's not vertically in situ, in that because of the erosion of the organic soils here, or whatever organic soils did exist, this is the wall that's been let down onto the eroded surface. And as always, poor sheep get a lot of the blame for this, and we can see them just about getting everywhere. And it's not difficult to imagine them causing very extensive soil erosion over large areas. In the south, we've already talked about the site of Kettlestead here, and let's look at that in a bit more detail, because it has a rather interesting, some interesting features associated with it. And here at Kettlestead here, below the Myrdalsjökull ice cap, one might imagine what things might have been during the Little Ice Age, when ice would have descended much lower towards any settlements. But anyway, let's look at the Norse period, and in here we have a mire, and within that mire, within the ditches that crisscross the mire, there's a very well demarcated ash, the Katla 1357 ash, and also pits that seem to be full of ash. And if you look at a section through this, you can see lots of tephras, which can give us lots of chronological information, and also a layer of turves, peat turves. Let's look at the pollen diagram from there. Here's the Landndim ash. As we saw before, hardly any woodland at all here. That's the birch curve. So largely unwooded throughout the Norse period and beyond. And things only really got underway at this site at about AD 1075. And then we have the deposition of that massive ash layer, the Katla 1357 layer, and that's when the turves are located, and the pollen within those turves, because that will be old peat that formed sometime, obviously formed before the mire peats that you see before that, those peat, the pollen within the peat there follows very closely that we see that dates before the Landndim period, indicating that the turves are old peat, unsurprisingly, and then we get more activity going on from AD 1416 onwards. We have some suggested barley type pollen, well, not suggested, it is barley type pollen, but it could indicate, it could suggest cereal, but notice that some of that is pre-Landndim, and this area has lots of, at the present day, lots of lime grass, which produces hordeum or barley type pollen, and so I don't think one can see all of this as being a result of arable activity. But what we do see in the horizons where we begin to see agricultural activity, mainly pastoral, within the record, we see insect evidence of animals. Here's Aphodius slaponis, the work of Paul Buckland and Eva Paniagiotopoulou, suggesting that this is indicative of human activity, because these are dung beetles which greatly expand at this time, and so we have this coalescence of proxies. And indeed, right beside the mire we have these old fields. And looking again at all the tephras there, we have lots of them, and there seems to be a vegetational response to about half of them in terms of tall herb species growing. So these are the ones that could, their heads are above the parapet, as it were. They're above the tephra layer, and they're able to survive. But when we have that massive layer, we start to get better drainage, and the tephra can act as a mulching effect. But if you've got better drainage, then you can be sounding the death knell of those insect species like Hydrina brittani, which are like damp conditions, and this seems to be the end of it. There may be a climatic cause as well. But what about these the pits that we saw? We look at the tephras here, and we look to one side of this. We can see that this pit is full of Catla 1357 tephra. There's the turves on top of that, and the Catla 1416 ash above that. So we're getting quite a lot of chronological control here. And we can look around the area of the mire. We can look in the ditches, and we can do look at geophysical survey, which suggests that there are something like 40 pits, which probably mean there are a lot more, because this is in a very small area. So what were all these pits? Were they artifacts of drainage? Well, they're very close together, so it makes that rather unlikely, I think. And the drainage ditches could continue to function even if they were tephra filled. It doesn't seem to relate to that. Were they a receptacle for the 1357 tephra? But why bother to go to that through that when you could just create clearance mounds of tephra, which would make life a lot easier? Were they retting pits? They're discrete, perhaps for flax or hemp. And we can see this, for example, in similar pits in Lincolnshire that we use for hemp or flax. Peat cutting, though. The cuttings would have been too deep for the building turfs, which would really be looking for the more minerogenic surface turf rather than the deeper, more organic peat, which would be okay for use as fuel or bedding. And we can see pits here which probably fit the bill a lot better, and this is at Hof, just along the coast from Ketelstadia. And we can see fossil peat digging pits, probably peat digging pits elsewhere in Iceland. And it puts one in mind of going back to Viking homelands, in this case Denmark. This is in Jutland, where we have lots of pits of similar size as well, although these are of Iron Age date and seem to be associated with some kind of ritual, because they contained various artifacts also. But one can imagine that if you've got tephra that's being deposited in an area with pits, then why not shovel into them if the elements aren't doing it for you anyway? And if you have deposition of ash from volcanic eruptions, then you're going to need to do something. Because here's an example of this. You need to remove this in order for animals to get back at the grass. Was the turf put on top in order to, was it simply just part of the peat digging process, or was the peat being placed on top and around volcanic ash in order to try and bring back some to enrich that land after a particularly deep tephra fall? Here's an example of a tephra fall in these areas, and you can see this is, if this suddenly dumps on top of your land, then you've got a real problem. And this after the most recent Eyjafjallajökull eruptions. You've got to do something, because the tephra contains a lot of toxins adsorbed onto the surface, fluorides, chlorides, onto the surface of the tephra grains, and if the animals ingest this, then they can eventually die, as indeed these sheep, as has happened to these sheep. And let's finally move down to look at what can happen over time and environmentally when we look at abandonment. Let's look at the south of Iceland a bit further. Here we can see settlement from abandonment during the prior to the Little Ice Age, and not a great deal was abandoned here. But when the Little Ice Age occurred, then we start to see a sixfold increase in abandonment. And you can look at the reasons for this, and going back to the kind of modelling that we saw for the pharaohs, we can ask ourselves if the land could take what was going on here, if people started to, if populations expanded and the number of animals increased. And modelling here does in fact suggest that there's no evidence of a crisis from the amount of available biomass. Of course, how that biomass is used is a completely different matter. But there was enough growth of crops here through time to keep these animals alive. There shouldn't necessarily have been settlement abandonment, but we did have soil erosion and we did have degradation. It still happened within the area, and one asks whether this is an inability to track unpredictable courses of rapid climate change. And also whether there's a cultural explanation for the destruction of these rangelands. Well, people were aware that things were going wrong, and this is why they have laws. And we have the Grégas Commonwealth period laws in Iceland, followed by the Jonsbok ones, and these were talking about grazing rights and the number of sheep you could keep on an area. There were penalties associated with this, and it's in detail right down to the week in June or September when you had to move your sheep or stop grazing. So people were aware of things going on, but we still had degradation. And one inference that can be made from this is that the failure to move livestock around or to remove it before the end of the growing season, because we've seen that there was enough biomass around, were perhaps very likely to contribute to land degradation rather than the absolute numbers of the animals involved. Plus the fact that as we're getting towards the colder conditions of the Little Ice Age, there was folk memories are perhaps not long enough, and you can't really keep patterns in your mind and you can't track this. But there wouldn't have been enough knowledge necessarily of the environmental conditions changing for people to actually do something about that. And it's rather more complicated than I'm able to explain here. But change was obviously occurring, though, as we know, people survived. And people at the time, all of this was going on, all these changes and all this fairly rich development of settlement within Iceland, people were at the same time thinking of moving on. And that's exactly what we're going to address. The movement of peoples from quite an early stage from Iceland to Greenland in the next lecture.